To do a one-way analysis of variance, you will need two variables in the dataset. One nominal or ordinal independent variable. I'm going to be using year, which ranges from 1 to 4. And you'll also need a continuous dependent variable, and I'm going to be using final percent grade. So to do the analysis, you go to Analyze, Compare Means, and then Way ANOVA. In the dialog box, you'll have to enter the dependent list, which is just your dependent variable, so I'm going to put final percent grade in there, and your factor, which is your independent variable, so I'm going to be using year in school. You also have to click the options button here and click off descriptive statistics, homogeneity of variance, because we're using a between groups independent variable, and the means plot. Then press continue. At this point, we don't know whether we want to do any sort of post hoc analysis, so we don't have to click anything for now. So press OK. And SPSS will give you the following output. First, you get the descriptive statistics for each of the levels of the independent variable. In this case, we have 4 different levels or 4 different years in school, and we get the means and standard deviation for each group. Then you will get the test of homogeneity of variance. This might look slightly different if you're on a Windows machine, but essentially you will read the top line, which says, I think, based on the mean, or on a Mac it'll look like this and you only have the one line to read from. You can interpret this the same as always. I've done another video of this, so I'll just briefly go over it. Here, our Levene's test is not significant, which means we can assume equal variances. So unlike the independent samples t-test, where Levene's test will tell you which row to read in the table, there's no different rows to read in an ANOVA. So what the implications are for the post hoc test that you will choose, if a post hoc test is necessary. Then you're given the source table, which is your ANOVA table, and your significance of the f-test. So in order to report this, you give the f statistic to 3 decimal places, the degrees of freedom for the numerator and the denominator, and the significance to 3 decimal places. So in this case, this is sometimes called the omnibus test, which means that this test is looking for some sort of difference between all 4 of these groups. Okay, so it's not doing a pairwise comparison like a t-test, not just between 2 groups. It's looking for overall, within all of the groups, is there some sort of significant difference? So here we find that there's no significant difference. Because there's no significant difference, it's not necessary to do any post hoc tests. Here we're given the means plot, just so that you can see a plot of how the groups differ on the dependent variable. If your test is significant, then you have to make the decision on whether to do a post hoc test. And the rule is that if it's significant, and if your independent variable has more than 2 groups, then it's necessary to do a post hoc test to figure out where the differences are. So this is not significant, but I'm going to go back and show you how to select a post hoc test just as an example. So you go back into the Compare Means Way ANOVA. It'll have everything that you've already inputted here, but this time you can click on the Post Hoc button, and this will give you a bunch of different ways to conduct post hoc tests, each calculated in slightly different ways or making slightly different adjustments. Each one of these is used in very specific cases, but in general, the default one, especially if there's no violation of homogeneity variance, it's in the equal variances assumed box, you will be choosing Tukey. So press continue and then OK. And this will give you the same output, except you'll also get the multiple comparisons table and the homogeneous subsets table. And these two tables give you the exact same information, but they are presented in slightly different ways. So I'm going to focus on this one because this format is used for a number of different common post hoc tests, whereas this one is something you only get sometimes for Tukey. So in the multiple comparisons table, this will take each level of the independent variable and compare it in a pairwise comparison to every other level of the independent variable. So this is, each freshman year is compared to sophomore, junior, senior, and so on in all combinations. So this table is going to have a lot of repetition because the comparison between frosh and soph is going to be the same as soph and frosh. So there's going to be at least double of everything. So what you'll have to do to read this table is to look at the pattern of significance using this column here, the p-value of each comparison. In this case, our omnibus test wasn't significant, so we're not going to find any significant difference. But in other cases, you may find that certain pairwise comparisons are significant.